Have you ever stopped to think about how we actually know what's going on miles beneath our feet? How we take the pulse of our planet? Well, today, we're diving deep into the world of downhole data, the amazing tech that basically gives the Earth a full-blown health checkup.
So what does a checkup for the Earth even look like? I mean, it's not like you can just use a stethoscope, right? We're trying to measure vital signs in one of the most hostile, inaccessible places you can possibly imagine. And getting it right is crucial for how we manage our planet's resources.
And this is exactly why it's so hard. The downhole environment is like another planet. You've got pressures that can literally crush steel, heat that's well beyond boiling, total and complete darkness, and it's all miles underground. This isn't just an engineering problem. It's like a mission into the abyss. For a long time, our main tool for this mission has been the wireline. The best way to think of it is as an umbilical cord. It's this heavy-duty cable that lowers tools down, gives them power, and acts as a physical highway to send data back up. For decades, it was pretty much the only game in town. But, and this is a big but, there's a catch. The wireline itself, this giant cable hanging in the well, can actually mess with the measurements you're trying to take. It can block the flow, change the pressure. It's like trying to take the temperature of a hot coffee with a giant ice cube. Your measuring tool is changing the result of the experiment. So yeah, we needed a much smarter way to listen.
And that brings us to the first big innovation here, finding smarter ways to listen. The goal was simple, but honestly, it was revolutionary. How do you get all that critical data, but without your own tools messing up the results? This slide just perfectly captures the whole shift in thinking. We're moving away from the old problem, this constant clunky wireline connection, to this new, much more elegant goal of data on demand. The idea is to get the info you need exactly when you need it and then just get out of the way.
So how do we actually do that? Well, engineers came up with three pretty incredible solutions. There's the DataLatch System, which is all about recording now and retrieving later. Then there's wireless telemetry, which sounds like sci-fi because it kinda is. And for the long haul, you have permanent sensors. Let's break them down.
Okay, first up, the DataLatch System. This is just pure elegance. You run the tool down the well and just let it do its thing, you know? It records all the important stuff, pressure, temperature, right onto its own memory. Then, whenever you're ready, you lower a wireline, latch on real quick to grab the data, maybe give it some new instructions, and then pull the wireline back out. It's so smart.
Now, the secret sauce that makes this all possible is called latched inductive coupling. And honestly, the best way to picture it is just like the wireless charger for your phone. But instead of charging a battery, it's transferring data using electromagnetic fields, and it's doing it miles underground. Just an incredibly clever piece of engineering.
All right, let's move on to our next solution. If DataLatch is clever, wireless telemetry is kind of mind-bending. Instead of any kind of cable, this tech uses the Earth itself to send the signal. It blasts low-frequency signals right through the rock, from an antenna deep in the well to one on the surface. I mean, you are literally talking through miles of solid rock. It's wild.
And finally, for situations where you need to keep an eye on things for years, we have permanent sensors. These are actually installed on the outside of the well's piping and hardwired straight to the surface. It's like giving the well its own permanent nervous system, so you can get a continuous, real-time data stream for its entire life. Okay, so we've figured out how to get data to the surface without getting in the way. That's awesome. But what if you need more than just a general reading? What if you need a super precise diagnosis from one very specific spot? Well, that's when we enter the world of formation probing.
This is where a tool called a formation interval tester comes in. It's a really sophisticated piece of kit that you can lower down to a very specific depth. And there, it can perform these little mini tests that tell geologists everything they need to know about the rock's health and what kind of fluids are inside it.
And I just love this analogy because it is absolutely perfect. Using one of these testers is truly like being a doctor for the planet. You're using a tool that's part syringe to draw a little fluid sample and part stethoscope to listen to how the reservoir's pressure responds. It's brilliant. So how does this planetary checkup actually work? Well, the tool pushes a sealing pad called a packer right up against the wall of the well. Then, a tiny probe punches just a little way into the rock. It sucks out a small fluid sample. And this is the critical part, it measures every little change in pressure while it's doing it. And that data tells you a ton about the rock itself. Now, let's take that whole concept and just put it on steroids. Meet the Modular Dynamic Tester, or MDT. This thing isn't just a single tool, it's an entire platform.
It is the absolute peak of formation testing technology, a true Swiss Army knife for any geologist.
And really, the best way to understand the MDTM is to think of it as a Lego set. Seriously, instead of one tool that does one thing, it's a whole bunch of different modules that you can snap together in any combination you need for the job you're doing that day. That modularity is its superpower.
And what a toolkit is! You've got your basic probes, of course, but you can also add a pump-out module to clean things up, a packer module to test a bigger area, and, my personal favorite, an optical fluid analyzer to see exactly what you're sampling in real time.
Let's talk about that pump-out module for a second, because it's so important. When you drill a well, the drilling mud you use actually seeps into the rock right around the borehole and contaminates it. The pump-out module acts like a filter. It sucks out all that contaminated gunk first, making sure the sample you finally take is 100% pure fluid from the formation.
And this is where it gets really amazing. The optical fluid analysis module actually shines infrared light through the fluid as it's being sampled. And because oil, water, and gas all absorb light differently, it can tell you the exact composition of what you're looking at right then and there, miles underground. No more waiting, no more guessing.
The packer module is another absolute game changer. A standard probe tests a tiny spot, maybe a few inches across, but the packer module, it has these inflatable parts that seal off and test an entire section of the wellbore, sometimes several feet long. You go from a tiny pinprick test to a comprehensive physical exam of an entire zone. Okay, so we've got all this incredible technology. Data latches, wireless signals, modular testers, the whole shebang. But why? What does getting all this super detailed data actually unlock for us back on the surface? Why does all this matter? Well, the payoff is immense. It leads to way more efficient energy extraction, it helps us reduce financial and environmental risks, it gives us a much deeper understanding of our planet's geology, which is critical for things like carbon capture. Ultimately, it just lets us be much, much smarter about how we manage our planet's resources.
And all this really brings us to one final big question. For the first time, we have developed these incredible tools to listen to the Earth's deep, hidden conversations with breathtaking detail. So now that we can finally hear it so clearly, what do you think it's going to tell us next?